Hello everyone, welcome to Brain Blitz Audios. In this episode of Cbse board exam, we'll be dealing with previous year questions of mathematics asked in Cbse board exams. And the chapter that we'll be dealing with today is the fourth chapter of your grade 12 syllabus, Determinants. Let's look at our first question. This is comparatively simple. Write the value of the determinant, and we have a determinant here. P plus 1, P minus 1, and P. So, to find the determinant, what we do is we multiply these two. So that is P into P, and minus the product of these two. So that is P minus 1 into P plus 1. P into P is P squared minus P minus 1 into P plus 1. This is similar to A minus B into A plus B. And that would be equal to A squared minus B squared. So P squared minus of P squared minus 1. Putting the minus inside the bracket, we'll get P squared minus P squared plus 1. P squared minus P squared is 0. So our determinant is 1. The value of the determinant is 1. Now let's look at something a bit more complicated. Using the properties of the determinants, prove that A squared, BC, B squared, CA, and C squared, AB will be equal to A minus B into B minus C into C minus A into BC plus CA plus AB. How do we go about this one? Let's take the LHS as A squared, BC, B squared, AC, C squared, AB. Now, what we do is we interchange the rows and the columns. So no change in value of determinant when rows and columns are interchanged. This is a fundamental property. So there'll be no change in the value of the determinant if we take this first row as the first column, and so on. So we have A squared, BC, B squared, AC, and then C squared, AB. This is the value of our determinant. Now what do we do? Over here, we have to multiply something in order to make the columns having some common factor. So what we do is our change is C1 changes to AC1, C2 changes to BC2, and C3 changes to C3. Therefore, our determinant will be 1 by ABC because it has to be equal. So we multiply and divide by ABC. And then in the determinant, it will be A squared, A cubed, ABC, B squared, B cubed, ABC, C squared, C cubed, and ABC. Now, we find that ABC is common across the third row. So what we do is we take ABC common from row 3. So that will be ABC divided by ABC into A squared, A cubed, 1. B squared, B cubed, 1. C squared, C cubed, and 1. Now, what change do we do? In order to find the determinant, we need to make sure that one of the rows or columns have the maximum number of zeros. So our transformation should be made accordingly. So we notice that this one can be made into zeros quickly. So what we do is we take C1 changes to C1 minus C2. When that happens, so ABC by ABC becomes 1 because they cancel each other out. So value of the determinant, a square minus b square, a cube minus b cube. 1 minus 1 is 0. Then we have b square, b cube, 1, c square, c cube, and 1. Similarly, we'll take C2 as C2 minus C3. So C2 changes to C2 minus C3. What happens next? A square minus b square, a cube minus b cube, 0, already present. Now b square minus c square, and then b cube minus c cube, and then 0. Then c square, c cube, and 1. But hold it. We're not finished yet. We can still take common factors out. So on expanding, a square minus b square is a plus b times a minus b. And a cube minus b cube is a minus b times a square plus ab plus b square. And 0. Now, second column, b plus c into b minus c. That will be b squared plus c squared. And b cube plus c cube is b minus c times b squared plus bc plus c squared. And then 0. C squared, c cube, and 1. Now, we'll take a minus b common from c1 and b minus c common from c2. So that will be equal to a minus b is outside, b minus c is outside of the determinant. So we'll have a plus b, b plus c, c squared. Then we'll have a squared plus ab plus b squared. And then b squared plus bc plus c squared. And then c cube, 0, 0, 1. Now we take determinants. So we expand along R3. So the value of the determinant will be a minus b into b minus c into, so there'll only be one element, and then the expansion will be a plus b, b plus c, a square plus ab plus, okay, let's clean that out. And so we'll get a square plus ab plus b square and b square plus bc plus c square. Now we have to take out common factors again. So now what do? We'll take c2 as c2 minus c1. So c2 changes to c2 minus c1. Therefore, a minus b times b minus c. Again, this mistake. So let's rub it to avoid confusion. So a minus b into b minus c into, whether you represent one or not, it doesn't matter. And then a plus b, first row, no change. First column, no change. A square plus ab plus b square. Again, no change. Now here, it is b plus c minus a minus b. And over here, it is b squared plus bc plus c squared minus a squared minus ab minus b squared. So let's simplify it. So a minus b times b minus c times the determinant of a plus b and a square plus ab plus b square. And then on C2, it becomes c minus a. And this will be c square minus a square plus bc minus ab. Now what do? Let's simplify this further. So we'll get a minus b into b minus c into the determinant a plus b, a square plus ab plus b square. And then over here, c minus a. And on the second term, we try to take c minus a common. So c square minus a square. So that will actually become c plus a into c minus a, and then plus b into c minus a. So take c minus a common from C2. So we'll get a minus b times b minus c times c minus a, and then the determinant a plus b, a square plus ab plus b square, 1, and c plus a plus b. Now we can take the determinant of this. We can expand it. So a minus b times b minus c times c minus a times a plus b into c plus a plus b, and then minus a square plus ab plus b square. On expanding, you will get a minus b into b minus c into c minus a into, so we'll get ac plus bc plus a square plus ab. So then plus ab plus b square. And then here, if we take the minus into the bracket, we'll get minus a square minus ab minus b square. So over here, we can cancel an a square, we can cancel an ab, and also a b square. So finally, what we have left, the LHS, will be equal to a minus b times b minus c times c minus a times ab plus bc plus ca, which, according to our question, is equal to the RHS. Hence proved. So there is the solution to our question. Now, our next question. If A is equal to 2, minus 1, 1, 3, 0, minus 1, 2, 6, 0, so this is a matrix, find A inverse, and then using that A inverse, solve the following system of equations. 2x minus y plus z is equal to 3, 3x minus z is equal to 0, 2x plus 6y minus z is equal to 2. Second equation can be written as 3x plus 0y minus z, which is equal to 0 for convenience. Now what do? Now we know that A is equal to 2 minus 1, 1, 3, 0, minus 1, 2, 6, 0. First thing we do is we take the determinant. Determinant of A will be 2 times the determinant of these 4 digits. That'll be 0 minus minus 6, so that is plus 6. And then minus of minus 1, because that minus is for the place. So minus of minus 1 times, so first row is gone, second column is gone. 3 into 0 is 0. Minus 2 into minus 1 is minus 2. So 0 minus minus 2, so that is 2. Then plus 1 into, so that is first row, third column. It'll be 3 into 6, 18, minus 2 into 0, 0. So 1 into 18. So that will be 12 minus 2 plus 18, which will be equal. I mean, it's not actually minus, it's plus, because minus of minus 1. So it's 12 plus 2 plus 18, which is equal to 32. Now 32 is not equal to 0. That means determinant of A is not equal to 0. So what that means is that A inverse exists. So by taking the determinant of A and taking it as not equal to 0, there exists an A inverse. And we need to find that A inverse. But before that, let's take the cofactors of the matrix A. Cofactors. So the first term, A11, it'll be equal to the determinant enclosing that. So that is equal to 6, or let's write it down just for this one. 0 minus 1, 6, 0, which is equal to 0 minus of minus 6, which is equal to 0 plus 6, which is equal to 6. A12. Now that will be 1, 2, 3, 4. So it'll be 3 minus 1, 2, 0, the determinant. There'll be a minus because it's 1, 2, so it's odd. And then we'll get 0 minus minus 2, which is equal to 0 plus 2. But all of this has a minus outside it. So therefore, A12 is minus 2 instead of 2. Now A13. So over here, what we do is we take these two invalid. So 3, 0, 2, 6. 3, 0, 2, 6. Now 3 into 6 is 18. These are positive. 3 into 6 is 18 minus 2 into 0 is 0, which is equal to 18. A13. Now let's take A21. A21. So second row and first column are discarded. So we get minus 1, plus 1, 6, and 0. Minus 1, 1, 6, 0. And it is also negative because odd. So minus of minus 1 into 0 is 0, minus 6. So that is minus of minus 6, which is equal to 6. A22. So second row, second column, so that is 2, 1, 2, 0. 2, 1, 2, 0, which will be equal to 2 into 0, which is 0, minus 2, which is equal to minus 2. Now let's take A23. A23 is second row, third column. 2 minus 1, 2, 6. 2 minus 1, 2, 6, which will be equal to 12. It's actually negative, so minus of 12 minus 2, which is equal to It's 12 minus minus 2. So it'll be minus of 14, which is equal to, yeah, it's minus of, let's write that down as 12 plus 2. So minus of 12 plus 2, that's minus 14. Now let's take the third row, A3, 1. Go back to our matrix. So third row, first column, minus 1, 1, 0, minus 1. Minus 1, 1, 0, minus 1. So determinant of that, minus 1 into minus 1 is 1. Minus 0, that is equal to 1. A3, 2. Third row, second column, discarded. So 2, 1, 3, minus 1. 2, 1, 3, minus 1, which is equal to, and this it's always a minus. So minus of minus 2, minus 3. So minus 2, minus 3. So that's minus of minus 5, which is equal to 5. And then A3, 3. That'll be equal to third row, column. So 2 minus 1, 3, 0 inside the determinant. 2 minus 1, 3, 0. So that's in the determinant. So 2 into 0 is 0. Minus of minus 3. That is equal to 0 plus 3, which is equal to 3. So we have our cofactors for each of the terms of the matrix, each of the elements. Now, let's take the adjoint of A. The adjoint of A will be 6 minus 2, 18, 6 minus 2 minus 14, 1, 5, 3. So these are the cofactors, matrix of the cofactors, and we do the transpose of it. So we'll get 6, 6, 1, minus 2, 5, 18, minus 14, and 3 as our adjoint. Now, we were asked to find A inverse. So A inverse is equal to 1 by determinant of A times adjoint of A. 1 by 32, because 32 is the determinant of A. So 1 by 32 times 6, 6, 1, minus 2, 5, 18, minus 14, and 3. So instead of multiplying, let's keep it as it is because that makes calculations easier. Now for the given system of equations, the matrices that we get is 2, minus 1, 1, because it's 2x minus y plus z. And then it's 3x plus z, so 3x plus 0y minus z. And then 2x so it'll be 2x plus 6y minus z. So these are the coefficients. Now x, y, z, that will be equal to the products minus 3, 0, and 2. Now let's take this matrix as A, this matrix with the variables as x, capital X, and the matrix with the RHS as B. So AX is equal to B. Now what do? We pre-multiply by A inverse. So A inverse times A times X is equal to A inverse times B. A inverse times A is I, so Ix is equal to A inverse B. So I multiplied by any matrix X is equal to the same matrix. So x is equal to A inverse B. So the value of x is the matrix x, y, z. A inverse is 1 by 32 times 6, 6, 1, minus 2, minus 2, 5, and 18, minus 14, and 3. Now what do? We multiply it with b, and b is minus 3, 0, and 2. So as you can see, it's 3 by 3, and we have a 3 by 1 matrix. So we'll get a 3 by 1 matrix. This is an easy way to find out the order of a matrix, which is the multiple of two matrices. This is the way. So when these two are equal, then the matrix is able to be multiplied. So now 1 by 32 times the multiplication of these two. So how do we do it? 6 times minus 3, that is minus 18, plus 6 times 0, that is 0, plus 1 times 2, that's 2. So this is one term. Next term. But before that, let's kind of modify our brackets. So, okay. And then moving on to the second multiplication. So second row times this matrix. Minus 2 times minus 3 is 6. Minus 2 times 0 is 0. Plus 5 times 2 is 10. So that is the second element. The third element, 18 times minus 3 is minus 54. Plus minus 14 times 0 is 0. Plus 3 times 2 is 6. On adding, we'll get 1 by 32 into the matrix will be minus 16, 16, and minus 48. Now we divide it by 32. So it will be minus 16 by 32, 16 by 32, minus 48 by 32. This is our matrix. However, the matrix XYZ can be further simplified using 16. So minus 16 by 32 is minus 1 by 2. 16 by 32 is 1 by 2. And minus 48 by 32 is minus 3 by 2. So therefore, on comparing, we'll get x is equal to minus half, y is equal to half, and z is equal to minus 3 by 2. So that was our question. So we found A inverse and we solved the following system of equations. We found x, y, and z. So that is all from this episode of CBSE board exam. For more of our useful content, please subscribe to our channel, Brain Blitz Audios. So we'll be back with more educational and interesting content such as mind maps, learner words, etc. So until then, take care, stay safe. Ta-ta for now.